Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, we'll continue further with Mathematics class 11th. The chapter that we're dealing with is sequence and series, and now is the turn of miscellaneous exercise. In this exercise, obviously, there will be questions from arithmetic progression, geometric progression, and special series as well, right? So we'll be seeing each and every question over here. Some very interesting questions have been asked in this exercise. Let's move on to the first question without wasting any further time. The first question of this miscellaneous exercise, as you can see, is this. Okay. And what do we have? Show that the sum of m plus nth and m minus nth terms of an AP is equal to twice the mth term. Okay. So, we are talking about sum of m plus nth and m minus nth terms of an arithmetic progression. Let us say arithmetic progression be a plus d, a plus 2d, comma, dot, 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 something of this sort, right? And when we talk about m plus nth term, a m plus n, what will that be? That will be a plus m plus n minus 1 d. Then you have m minus nth term, which is equal to a plus m minus n minus 1 times d. This is what you have, right? Sum of these two terms is equal to twice the mth term. What is mth term? am is equal to a plus m minus 1 d. Okay, so we are supposed to prove a m plus n plus a m minus n is equal to twice a m. This is what we are supposed to prove. Okay, now this is one of the properties basically of arithmetic progression, that from any term, if you take two terms equidistant on both sides, from any point term, if you take one term ahead, let's say 5 units ahead and 5 units behind, and you add those terms, what you'll get is twice this particular term, or basically you can say that this term is arithmetic mean. This term is arithmetic mean of that term which is ahead and the other term which is at the back, similar distance back, right? Okay, equidistant, that's what you can say. So this property is directly from this particular result directly follows from that property of arithmetic progression. And how can we prove that, right? This is a proof basically. Let's take a look at the proof. So for proof, what do I need? LHS, left hand side, is a m plus n plus a m minus n. What is that equal to? This is a plus a 2a plus, what do we have? M plus n minus 1 plus m minus n minus 1 times d. This is what you have, and n gets cancelled. As you can see, 2a is okay, plus this is 2m minus 2, 2 times m minus 1 d. You can take out a 2 common, and what remains is a plus m minus 1 d, which is 2 times a m. This is what we can see. So we started with LHS, and have we reached the RHS? Yes. Hence, proved. That's a complete proof of this question. Important property from arithmetic progression, and which has been discussed over here, right? Question number 2 says, if the sum of three numbers in AP is 24 and the product is 440, find the numbers. Okay. When you are asked to find three numbers in arithmetic progression whose sum is already given, so three numbers in AP can be considered as, one of the choices is that you go with a plus d, a plus 2d. But rather than that, if you go with a minus d, a plus d, calculations will become easier, right? Since the sum is directly given to you, see that the sum of these three numbers is 3a. If that is equal to 24, you directly get the value of a, which is one of the parameters. The other parameter d can be found with another condition given. Right. In case the person says four numbers in AP and he gives a sum, what can you take as four numbers? A minus 3d, a minus d, a plus d, a plus 2d, a plus 3d. Again, if you see in this particular arrangement, the sum of all these numbers is 4a, right? If you are given four numbers in AP and the sum is also given, you can directly take the numbers as this, and you directly get the value of a, right? One of the parameters is solved with one condition directly. The important thing to note in this one is that common difference is not d, it is As you can see, 2D. 2D is the common difference, right? Take care of that. So here the person says if the sum of three numbers in AP is this, so let three numbers be A minus D, A plus D. Once you have this, therefore sum is equal to 24 implies 3A will be 24 and that tells me A will be 8. This is what you'll get, right? And the product is 440. Product is equal to 440, which implies A minus D, A plus D. A times A square minus D square is equal to 440. And since we have already found A, can I substitute that over here? This is 864 minus D square is equal to 440. And now can you solve easily for the value of D? Yes. 8 gets cancelled, 64 minus D square is equal to 8, 5 and 5. That tells me D square will be 64 minus 55, which is 9 over here. And once we have this, therefore D is equal to plus or minus 3. Okay. Find the numbers. Numbers will be, if you take D is equal to 3, what do you get? A minus D will be 8 minus 3, 5, 8 and 11 if you take D equal to 3. Or if you take D is equal to minus 3, you will get 8 minus or minus 3, 11, 8 and 5. This or this basically 5, 8 and 11 or 11, 8 and 5, they are same numbers basically, right? So that's my correct answer for this question using two different values of D obtained as you can see over here, right? Is that all in this question? Yes. Question number 3 says, let the sum of n, 2n and 3n terms of an AP, n, 2n and 3n terms of an AP be S1, S2 and S3 respectively. Show that this. Okay, for an AP, S1, S2, S3 are the sum of n, 2n and 3n terms of an AP and we are supposed to prove something, okay? So given S1 is equal to n by 2, 2a plus n minus 1 d. This is what you know. S2 is equal to 2n by 2, 2a plus 2n minus 1 times common difference. S3 is equal to 3n by 2. In the bracket we have 2a plus 3n minus 1 times d. This is what we have. This is given. And we are supposed to prove S3 is equal to 3 times S2 minus S1. This is what we want to prove. Okay. What else? Is there anything else? No, just that. So we can find S2 minus S1 somehow. Let's focus on finding S2 minus S1. S2 minus S1 is equal to what? Or should we say that we can finding basically RHS. We are simplifying RHS, which is equal to 3 times S2 minus S1, which is equal to 3 times in the bracket you have, okay, S2. S2 is 2n by 2, which is n times 2a plus 2n minus 1 d minus, this is a square bracket, okay, this is S2 minus S1 will be n by 2. In the bracket you have 2a plus n minus 1 times d, okay, like this. This is what you have in the RHS. So this will simplify to what? Let's take a look at this. 3 remains as it is. Within the brackets, what do we see? With 2a, let's see the coefficient of 2a. This is n and this is minus n by 2. This is the coefficient of 2a. What about d? The coefficient of d over here is 2n square minus n. 2n square minus n. And the coefficient of d from here will be n by 2 times n, which is n square by 2 with a minus. And minus of minus will become plus n by 2. This is what you get with 2a and d. This 3 is okay. 2a is also okay. N minus n by 2 is n by 2. Plus d is okay. 2n square minus n square by 2 will be 3 by 2 n square minus n plus n by 2 will be What will that simplify into? Minus n by 2 is what you get in the bracket, right? This is what you get. Do you see that n by 2 from here, n by 2 from here, and n by 2 from here will come out common? So this becomes 3n by 2. In the bracket you have 2a plus, what does this become? N by 2 comes out common, 3n minus 1 remains with d. And do you observe that this whole expression is nothing but this S3 over here? Yes, this is S3. And we started with the RHS. Have we reached the LHS? Yes, we have reached the LHS, and that's the complete proof of this question. Simple analysis? Yes, very simple analysis, not a difficult thing at all. Right? That's all that you need in this. But can you analyze this question from another angle, from a direct perspective, applying some common sense? Do we see? What do we have? This is S2 minus S1. Now what is S2 minus S1 actually equal to? So S2 is sum of from first to 2n terms. S1 is from first to n terms, okay? When you take the difference, you get n plus 1 to 2n terms. That's what you get, right? Okay. And what is S3? S3 is sum of this starting n terms, next n terms, and the next n terms as well. 1, 2, 3 n terms, right? Okay. And do you also know that terms equidistant from middle will be average, will give average equal to this central term, right? From any middle term, if you take two terms equidistant, what do we get? We get this middle term multiplied by 2, right? So now imagine this. This is basically a long series. Instead of n, imagine 30 terms. S3n, 3n, imagine 30 terms. So you have first 10 terms in the first 20 terms and first 30 terms. When you see the RHS, what do we have? We have first 20 minus first 10 is 11 to 20 terms over there, and that is multiplied by 3, right or not? Yes. What is that equal to? That is equal to S3, as the person says. S3 is simply this. First 10, next 20, next 10, and the last 10. The next 10 will be equal. That's not an issue. But what about these two terms? These two terms added together will be equal to twice this center term. Okay. First 10 and the last 10 will be added together, and they will be equal to twice the middle 10 terms. That's what you can see from here. Yes. So that's another way of looking at this whole expression, as you can see over here. And this is the general proof that we have discussed in this question. Is that okay? That's true for an arithmetic progression, and yes, we have analyzed this complete question thoroughly. Question number 4 says, find the sum of all numbers between 200 and 400 which are divisible by 7. Sum of all numbers between 200 and 400, okay, which are divisible by 7. So 200, is 200 divisible by 7? What 200 is not directly divisible by 7. What's the remainder that you get on dividing 200 by 7? Is 1. Basically 2 is 14, and then you have 60. So you needed 63, right? So 203 will be divisible by 7, yes. Okay. 203 over here will be divisible by 7. Sum of all numbers, so numbers divisible by 7 will be 203, not 207. 203. Okay. Then next number will be 210. Next number will be 217, and so on and so forth up till which number? Which number will you get next? So 400. If you divide 400 by this 7, frankly speaking, 350 is divisible by 7. 350 and 350 plus 49 is 399. 399 is divisible by 7. Yes. 399. Now 399 divided by 7 will give you 5 and 7. 57 as the quotient, right? This is what you get. Remainder will be 0, obviously, since this is divisible. So this is the sequence that we get. And this is an arithmetic progression, if you can clearly observe. Yes, common difference is 7. First term is 203, and the last term an is 399. And we are asked to find Sn. For finding Sn, we need n first of all, right? And n can be obtained with the help of this. So an is equal to a plus n minus 1 d, which tells me 399 is equal to 203 plus n minus 1 times 7. Okay, 399 minus 203, what is that equal to? This is 196. is equal to n minus 1 times 7, and that tells me n minus 1 will be equal to 196 upon 7. What is that? 140 is 20 and 28 is what I get. This is 28, which tells me n is equal to 29. That's one thing. Okay. Therefore, Sn, which will be n by 2, 2a plus n minus 1 d, or we can use n by 2 a plus a n. First term plus last term, that's what you can use. First term is equal to a. N is 29 by 2. In the bracket you have a which is 203 and plus an which is 399. This is what you get. So 599, 602. Okay, this is 29 by 2 into 602. What is that? 29 into 301 is what I get. Right? Let's multiply that. 29 into 1 is 29. 29 into 0 carried forward is 2. Will come over here. 29 times 3. What's that? 87. So this is 8729, and that is my required answer for this question number 4th, as you can see over here. Question number 5 says, find the sum of integers from 1 to 100 that are divisible by 2 or 5. Sum of integers from 1 to 100 that are divisible by 2 or 5. Okay. That's slightly more interesting. How? Because you can easily find the sum of integers divisible by 2. Let's denote it by S2. Sum of integers divisible by 5. Yes, we can also find that. But there will be certain integers which will be divisible by both 2 and 5. Yes. So what do we do in this case? Think of set theory. What is this? Let's call this complete set of integers from 1 to 100 will be inside this universal set, out of which some integers will be divisible by 2, some integers will be divisible by 5, and then there will be certain integers will be divisible by both 2 and 5. Now both 2 and 5, if an integer is divisible by both 2 and 5, then it is actually divisible by 10, right? So this intersection is actually S10. Yes or no? Yes. And if you want total n of A union B, you recall n of A union B is n of A plus n of B minus n of A intersection B. Okay. This in this case is n of S2. Basically S2. S2 is the sum of all of those. And then let's not use n of S2 because we are actually interested in S2, right? So the total sum that we are interested in is S2 plus S5 minus this S10, right? S10 will be added twice, so let's subtract that once. That's what we'll be using over here. What is S2? S2 is sum of all the integers divisible by 2. That's 2 plus 4 plus 6 plus dot 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 up till from 1 to 100. The person says from 1 to 100, that means that we have to consider 100 as well, right? Okay. What about divisible by 5? This is 5 plus 10 plus 15 plus dot 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 again up till 100. And we need to subtract S10. What is S10? S10 is 10, 20 plus 30 plus dot 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 up till 100, right? We'll be adding, these terms will be occurring twice in this, right? So we'll subtract it once. So the net sum that we need is S2 plus S5 minus S10. Okay, required sum is equal to S2 plus S5 minus S10. That's what we are interested in. So for that, let's find S2, S5 and S10 separately first. Here, S2 is equal to what? Do you see that I can take out a factor of 2 common throughout? And what do I get? 1 plus 2 plus dot 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 up till 50. Oh, what are we trying to do? We are simply trying to add the first 50 natural numbers, multiply them by 2 to get that sum. This is 2. 50 into 51 by 2. N into n plus 1 by 2. This is what you get. 50 into 51. Right? What is that equal to? So 552,550. What is S5? S5, again, I see a 5 coming out common, and what remains is 1 plus 2 plus dot 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 up till 20. This is what you get. So again, sum of first 20 natural numbers is what I need. 5 is okay. This is 20 into 21 by 2. This goes 10 times. And what do I get? 21 times 5 is 105. 0 is what I get. S10. Again, we need S10. Again, take out a factor of 10. 1 plus 2 plus dot 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 up till 10 will be remaining. And this is the sum of first 10 natural numbers. Yes. 10 is okay. This is 10 into 11 by 2. Yes. So this goes 5 times. And what do we need? 55 into 10, which is 550. So using these values, I can now find the required sum. What's that? This is 2550 minus plus 1050 minus 550. Right? So 2550 minus 550 is actually 2000, and you add this to 1050, this is 3050. That's my required answer for this question using the ideas discussed over here, discussed in this, and then some calculations required. Right? That's all that you have in this fifth question, as you can see over here. In the sixth question, the person says, find the sum of all two-digit numbers, which when divided by 4 yields 1 as remainder. Two-digit numbers, which when divided by 4 give 1 as the remainder. Yields means give 1 as the remainder. We are interested in two-digit numbers. Two-digit numbers start from 10 and go up to 99. Okay, and when divided by 4, the remainder should be 1. Okay, so sum that is required will be 10 divided by 4 gives a remainder 2. Okay, so we are interested in 13 then, right? 13 divided by 4 will give me a remainder 1. Then we have 13 plus. The next number that you will have is 17. Then you have 21, and similarly go ahead with 96 plus 1, which is 97. That's what you have. Right? So these are all the two-digit numbers which when divided by 4 yield 1 as the remainder. This is what you have. Yes. And can I find this sum easily? Yes, I can find this sum easily. This is an arithmetic progression for which A equals 13, D is equal to 4, AN is equal to 97. Can we get the value of N? Yes. Sn is question mark. N can be found by An, which is A plus N minus 1 D. What does that tell me? An is 97, which is 13 plus N minus 1 times 4. Let's use this to get the value of N. 97 minus 13 will be 84, divided by 4 will be 21, N will be 22. This tells me N will be 22. Okay. Therefore, Sn will be 22 by 2, A plus last term, which is 13 plus 97. First term plus last term, right? The formula that you have used is Sn is equal to N by 2, A1 plus An. Using this gives me 11 times, what is this? 90, 100, 110. What is that? 1210. That's the required answer for the sixth question, as you can see over here. Question number 7th says, if f is a function satisfying this, fx plus y is equal to fx fy for all x comma y belongs to natural numbers such that f1 equals 3 and sigma of this fx is equal to 120, find the value of n. Interesting question from the point of view of that something called a function is involved over here. Yes. And how will we handle this? Why is this question present in the chapter sequence and series? Let's see that. So first of all, obviously we should be getting some kind of a series over here. F is a function satisfying this. So let's see what type of function is this. F of x into f of y, and the person is saying that this is true for all x comma y belong to natural numbers. This is true for all this. F1 is also given. Okay. F1 is equal to 3 and F1 is equal to 3. If F1 is 3, that's the first term actually, right? First term. I want F2 somehow. So let's try and find F2. And for finding F2, do you see that I can put x, y equal to 1. This will be F1, this will be F1, which I already know. So put x equals y equals 1, and that tells me f of 2 is equal to f of 1 into f of 1. What is that? 3 into 3, which tells me f of 2 will be simply 3 square. That's what you see? Yes or no? Yes. So we have found f2. Yes. We need a summation up till n. So we are not seeing any pattern here as of now. Let's try to find f3. For finding f3, I can put x or y, either 1 equals 2, x can be 2 and y can be 1. f3 is equal to f2 into f1. Now f2 is already known. This is 3 square. f1 is 3. This is actually 3 power 3. f3 is 3 power 3. Yes. Now you can observe this is 3 square, this is 3 power 3, and similarly f4 will be 3 power 4. You can also observe that. Putting x equal to 2, y is equal to 2, you'll get f4, which is f2 into y, f2 into f2, which is 3 square into 3 square, that will be 3 power 4. You can clearly observe, right? So therefore, seeing this, fx is actually 3 power n, 3 power x actually. This is what you can observe. Okay. Therefore, sigma fx from x equals 1 to n is equal to what? This is 3 power 1 plus 3 power 2 plus 3 power 3 plus dot 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 up till 3 power n, and that is given as 120. So can you find the value of n now? Yes. This is a geometric progression whose sum will be first term. Common ratio raised to power number of terms minus 1 upon this minus this, which is 120. 3 goes 40 times. Yes, this is 2, will go over here 80. So 3 power n minus 1 is 80. What does that tell me? That 3 power n will be 81. 81 is 3 power 4 as well. Yes, yes. So that lets me know that n will be equal to 4. That's the required answer for this question number 7th. As you can see, first we have found fx using the given condition, right? Up till now we needed the knowledge of functions, and after that comes the knowledge of sequence and series. That's using sum of a geometric progression, right? That's all that you have in this 7th question. Question number 8 says the sum of some terms of a GP is 315, whose first term and the common ratio are 5 and 2 respectively. Some terms of a GP is 315, right? It's not given how many terms. First term and the common ratio are given. Find the last term and the number of terms. Okay. So n is equal to question mark. That's what is known. Sn is 315. That is given. A is first term and the common ratio. A is 5. Common ratio is 2. That's also given, right? Find the last term. So we are supposed to find the number of terms as well as the last term. Okay. That's the complete information of the question here. Okay, we are given A, R and Sn. Can we apply this complete result to get the value of n? Yes. Sn is A, R power n minus 1 upon R minus 1. That tells me 315 will be equal to 5 times 2 power n minus 1 upon 2 minus 1. Now 315 divided by 5. What will that be? This is 63, which is 2 power n minus 1. So that tells me 2 power n is 64, which is also equal to 2 power 6, and that implies n will be simply equal to 6. That's my first part. We have found n, the value of n. Now an will be a r power n minus 1. What is that? A is okay, 3, 5, sorry, a is 5. R is 2, power n minus 1. N is 6 minus 1, this is 5. So 5 into 2 power 5, which is 5 into 32, which is 160. That tells me an, that's the last term, will be 160. That's my required answer for this question, as you can see over here. In question number 9th, the first term of a GP is 1. The sum of the third term and fifth term is 90. Find the common ratio of the GP. So what is given? Given first term of a GP is 1. The sum of third term and fifth term is equal to 90. and find the common ratio of the GP. R is equal to question mark. Looks easy, right? A3 and A5 can be written as, this can directly be written as AR square. This is AR power 4 is equal to 90. What does that tell me? A is 1. So this is R square plus R power 4 is equal to 90. Or you can write this R square, this R power 4 plus R square minus 90 is equal to 0. And I can factorize this 90 to give the sum plus 1. So 90 can be written as 10 minus, so 90 can be written as 10 into 9. Yes. So this is R square plus 10 R square minus 9 R square minus 90 is equal to 0. Now do you see that I can take out R square common and what remains is R square plus 10. From here R square came out common, from here 9 with a minus comes out common. This is what you get. R square will be equal to 10 with a minus or 9. Now R square cannot be minus 10, which R square equals to 9 or R square equals 9, which tells me R is equal to plus or minus 3. And that is my required answer for this question, as you can see over here. Question number 10 says the sum of three numbers in GP is 56. Okay, three numbers in GP. Are we given the product? Had we been given the product, we would have assumed the numbers as A by R, A, AR. But the product does not seem, the sum of three numbers is given. Okay, so let the numbers be, by introduce A by R unnecessarily denominators, directly be A, AR, AR square. Okay, the sum of the three numbers is given as 56. So condition number 1, given, what is given is sum A plus AR plus AR square is equal to 56. That's one condition. If we subtract 1, 7 and 21 from these numbers, that is A minus 1, AR minus 7, AR square minus 21, these numbers are in arithmetic progression. Okay. If three numbers ABC are in arithmetic progression, can we say that 2B is equal to A plus C? Yes. So what do we have? A minus 1 plus AR square minus 21 is equal to 2 times AR minus 7. And this looks like the second condition. Yes? Yes. What will we do in this case? Next thing, we'll try to solve these two equations, 1 and 2, in terms of A and R to get the values of A and R. Yes. How will we do that? So this particular second equation can be simplified. We have A plus AR square over here. We have A plus AR square over here, which can be done as 56 minus AR. Minus 21 minus 2 is minus 22, which is 2AR minus 14, and that obviously tells me 3AR will be equal to 56 minus 22, which is, this is 56 plus 14, 70 minus 22. 70 minus 22 will be 48. That tells me AR will be 16. Okay, this is another equation. This is, let's call this third equation. And when can we use this AR equals to 16 in this? Again, one of the things that I can do is simply put AR equals to 16 and then get A plus AR square equal to 56. After that, substitute either A or R from this equation. Yes, I can directly substitute A or R. What I see is A times 1 plus R square is equal to 56. A is 16 upon R. 1 plus R square is 56. Okay, 16 and 56 will get cancelled. Yes, 8 times 7, 8 times 2 is what I get, and this becomes 2 plus 2R plus 2R square, which is equal to 7R, or you can say 2R square minus 5R plus 2 equals 0. Now this equation can be factorized to give you the value of R. How will we factorize this? 2 into 2 is 4, so you'll have to write 5 as sum of factors of 4, which is 1 and 4. So this 2R square minus 4R minus R plus 2 is equal to 0 is what I seem to get. One of the factors will be, you can take out 2R common. What remains is R minus 2. You can take out minus 1 common from here. This is what you get. equals 0, that tells me r will be equal to 1 by 2 or r will be equal to 2 from this factor or this factor, right? If r is 1 by 2, what is the value of a? A will be 16 upon 1 by 2, that is 32. Here a will be 16 upon 2, which is 8. This is what you get, right? Numbers will be a 32, ar which is 16, and ar square which is again multiplied by 1 by 2, this is 8. Those are the numbers. This, or the numbers will be a 8, ar 16 and 32. You can see the numbers are 8, 16 and 32. That's my required answer for this question number 10th, as you can see over here in this question. Question number 11 says a GP. It's not AGP, a GP. AGP is arithmetic or geometric progression, right? That's not what we're dealing with over here. We're simply dealing with the geometric progression. Consists of an even number of terms. If the sum of all the terms is 5 times the sum of terms occupying odd places, find its common ratio. That's what we are interested in, right? Given AR square is a GP having even number of terms. Even number of terms implies, let's take the number of terms as even. Let's take 2n terms. This will ensure multiplication by 2 will ensure that the number of terms are even, right? So having 2n terms, that's first thing. Sum of all the terms is 5 times the sum of terms occupying odd places. Okay. So it is given. Another thing is given. What's that? That a1 plus a2 plus a3 plus dot 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 plus a2n is equal to 5 times the sum of terms occupying the odd places. What is that? a1 plus a3 plus dot dot dot. Odd places would imply not a2n, but the series will end at a2n minus 1. Yes, this is what you get. Then find its common ratio. The person is asking common ratio r with the help of this idea. How will we handle this? Let's take a look at this complete question and see how will we handle this. What is a1, a2, a3 up till a2n? That's the sum of first 2n terms of a geometric progression, which is equal to first term common ratio power number of terms minus 1 upon common ratio minus 1. This is what you will get. Yes or no? Yes. What else? This is 5 equals, this is a1, a3. Okay. Do you see that a1, a3, you multiply with r square, you multiply with r square, you multiply with r square. So this is also a geometric progression. First term a1 and common ratio is r square. So first term a1, common ratio is r square, power number of terms minus 1 upon common ratio minus 1. Number of terms is just half, because total number of terms is even. We just consider odd terms. The total number of terms will be n. That's important. If you can write this carefully, then you are almost done. What does that tell me? A r power 2n minus 1 upon r minus 1 is equal to 5a. This is r power 2n minus 1 upon r square minus 1 can be done as r plus 1, r minus 1. You see, this gets cancelled, a gets cancelled, even r minus 1 gets cancelled, and what remains is r plus 1 is equal to 5. That tells me r will be equal to 4. That's my required answer for this question, as you can see over here. Is that all? Yes, that's all in this question. You can solve this question using another idea. That's basic common sense. How? You see, there are odd terms over here. There are odd terms and even terms both over here. Yes. So from there, can I cancel these odd terms once? So in the LHS, from here, I can also reach a2 plus a4 plus dot 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 plus a2n, cancelling the odd terms. 5 times a1 minus a1 will be 4 times a1 plus a3 plus dot 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 a2n minus 1. Yes or no? Yes. What is a2? a2 is ar. This is ar power 3 plus dot 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 dot. These are n terms. This is 4. This is a plus ar square plus dot 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 dot. N terms again. These are n terms, these are also n terms. Do you see that I can take out r common? This is a plus ar plus dot dot dot. This is 4 a plus ar square, just a moment, this was ar square, right? Plus dot dot dot. Now these are n terms, these are also n terms, exactly same n terms, and yes, these will get cancelled. What I get is r equals 4. That's another way of handling this. Yes, another way of handling this. We get the same answer, obviously we'll get the same answer, but this is also completely okay. Right? That's all that you have in this 11th question. Question number 12 says the sum of the first 4 terms of an arithmetic progression is 56. First 4 terms, and the person is talking about arithmetic progression and sum. The sum of the last 4 terms is 112. If its first term is 11, then find the number of terms. Okay, sum of last 4 terms is also asked. So we could have taken numbers as a minus d, a plus d, a minus 3d, a plus 3d for 4 terms of an AP, but that will give us a, but it will not give us any idea about the last 4 terms. True? So we'll begin with a simple idea that if its first term is 11, then find the number of terms. Its first term is already given to us. Find the number of terms, right? Sum of first 4 terms of an AP. So a1 plus a2 plus a3 plus a4. This is sum of first 4 terms of an AP is 56. 56, right? Sum of the last 4 terms is 112. Last term will be an. This is an minus 1, an minus 2, an minus 3, which is 112. That's also given, right? Last 4 terms. First term is 11. a1 is equal to 11. Find the number of terms. N is equal to question mark, right? And the series is an arithmetic progression. a1, a2, a3, dot dot dot, Rn AP. This is also given, right? Yes. So can I use this, since I've already given a1, this is 11 plus, this is 11 plus d, this is 11 plus 2d, the third term, fourth term will be 11 plus 3d, and that's given as 56. So can I use this? 11 plus 11 plus 11 plus 11 is 44, d plus 2d plus 3d is 60. 60 plus 44 is equal to 56. That tells me d will be equal to 56 minus 44, which is 12 by 6 is 2. Common difference is simply 2. That's what you can note. What about this one? Can I note something from here as well? an is okay, let it remain an. What is an minus 1? Is that not an minus d? From here to here you add a d, from here to here you will subtract a d, right? Similarly, this will be subtracting 2d. And an minus 3d, which is equal to 112. Yes or no? 4an, an minus 6d is equal to 112. 6d, what is 6d? 6d is 12, so that becomes 4an. That leaves us with 4an is equal to exo 112 plus 12, which is 124, and that tells me an will be 31. Oh, you have found an, you are given a1, and you are given d. Can you find n easily? Yes. An is a plus n minus 1 d. What does that tell me? This is 31, which is 11 plus n minus 1 times common difference 2. 20 upon 2 is 10, n minus 1 is 10, and that tells me n will be equal to 11. That's my required answer for this question number 12th, as you can see over here. Question number 13 says if a plus bx upon a minus bx is equal to b plus cx upon b minus cx is equal to c plus dx upon c minus dx, where x is not equal to 0, then show that a, b, c, d are in GP. Now, for showing a, b, c, d are in GP, what can we prove? A, B, C, D are in GP, that implies common ratio B upon A should be equal to C upon B is equal to C upon D, D upon C. See, this implies A, B, C, D are in GP. Since each of these is equal to the common ratio, right? So ratio of 2 consecutive terms, ratio of 2 successive terms will be same, right? That's what we have to prove. Okay. So that's our target somehow. Can we find B upon A somehow from here? Yes or no? By the way, we could also go ahead and show this, or A upon B is equal to B upon C is equal to C upon D. Mind you, this is also okay, right? That's not an issue, okay? Because you just have inverted ratios, that's it. Here also, you can take, okay, common ratio in this case will be R, in this case common ratio will be 1 upon R, for that matter. Common ratio will be R and this ratio will be 1 upon R. This will be equal to 1 upon R. Okay. What else? So, let's focus on this complete expression. A plus bx upon A minus bx, B plus cx upon B minus cx, C plus dx upon C minus dx. And the important thing that I observe over here is that I see C plus D, C minus D type of thing. Yes. A plus B, A minus B type of thing. Yes. Can you think of applying component and dividend? Or do you see that this has been obtained by applying component and dividend on something? So how will we get that original thing? We'll apply component and dividend on this thing. What does component and dividend say? This is an idea, a concept borrowed from the topic ratio and proportion. So if A upon B is equal to C upon D, this implies that A plus B upon A minus B will be C plus D upon C minus D. Similar step in left hand side and right hand side will make the two ratios still equal, right? And this particular step going from here to here is called componendo and dividendo. This is what we need, right? A plus B upon A minus B is equal to C plus D upon C minus D. Is that okay? Yes. So can we apply that? Okay, there are three ratios given over here. Doesn't make a difference. This and this. We'll apply component dividend on all. So A upon B is equal to C upon D is equal to E upon F. Had there been E upon F, E plus F upon E minus F would have come over here. Doesn't make a difference, right? So we'll apply component dividendo and on this. What do we get? Sum in the numerator A plus bx plus A minus bx. In the denominator you will get A plus bx minus A plus bx. Do you see this? Yes. This is B plus cx plus B minus cx. Numerator minus denominator. Minus B and plus cx is what you will get. Which is equal to sum of numerator and denominator C plus dx plus C minus dx upon C plus dx minus C and minus or minus dx. This is what you get. And now, after applying this step on this, do you see that certain terms will get cancelled? In the numerator, in the denominator, in the numerator, in the denominator, in the numerator, in the denominator. And what are we left with? 2a upon 2bx, 2c upon 2b upon 2cx, 2c upon 2dx. I cancel 2 and 2, 2 and 2, 2 and 2 from the numerator and denominator. And if all of these ratios are equal to lambda, then can you say that a upon b is equal to b upon c is equal to c upon d is equal to lambda x? Can you say that? Or more importantly, if these three ratios are equal, this implies that if these three are equal, then this implies that A, B, C, D will be in GP. Will be in GP. That's what you can observe. And that's the complete proof of this question number 13th, as you can see over here. Is that all? Yes. What will be the common ratio of this GP? That's the important thing to note. So common ratio is actually B upon A. That will be the reciprocal of this. That is 1 upon lambda x. Okay, that's all. Other than that, nothing else. This is question number 13th. Question number 14 says, let S be the sum, P the product, and R the sum of reciprocals of n terms of in a GP. Okay. AR square, comma, dot, 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 AR power n minus 1 is the GP. Let this as the GP. Then the person says S be the sum of this GP. Therefore, S is equal to A plus AR square plus dot, 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 AR power n minus 1, which implies S is equal to A R power n minus 1 upon R minus 1. That's one thing. P the product. P AR square dot, 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 AR power n minus 1. What is that? A power 1 is multiplied n times. So this is A power n. R power 1 plus 2 plus dot, 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 plus n minus 1. So this is sum of first n minus 1 natural numbers. This A power n is okay. R power, this becomes n minus 1 times n minus 1 plus 1, n upon 2. Sum of first n natural numbers is n plus 1 by 2. Sum of first n minus 1 natural numbers will be n minus 1 into n minus 1 plus 1 upon 2. That's what you'll get. What about the next thing? What's that? P the product and R the sum of reciprocals. What is that? 1 upon A. R power n minus 1. This is what you have. What is this? This is again a geometric progression. First term is 1 upon A. Common ratio is 1 upon R. So 1 minus 1 upon R raised to power number of terms upon 1 minus 1 upon R. This is what you have. Can I simplify this further? Yes. 1 upon A is okay. This is 1 minus 1 upon R power n, which is R power n minus 1 upon R power n. This is R minus 1 upon R minus 1 upon R. This is what you get. Capital R is this. And we are supposed to prove P square times R power n is equal to S power n. So, LHS is equal to P square times R power n. What is that? P squared, which is A power 2n. R power n minus 1 by 2 square will be this. R power n, what is R power n? R power n is this. 1 upon A power n, R power n minus 1 power n upon R power 2n. R power n upon R minus 1 power, just a minute, R power n is what we are interested in, right? So that will not be R power 2n. This is not R plus n plus n. This is R power n first of all, right? And this is R power n, this is this, right? That's what we are getting. Okay, and what does this become after this? You see, A power 2n, A power n will get cancelled to give you A power n, okay? R power n into n is n square minus R power minus n basically. So this is R power n which is R power n square upon R power n into, this is already taken care of. R power n minus 1 power n is something which we are interested in. R power n is something which will get cancelled, and what remains is R power n upon this. So this again gets cancelled. Yes or no? Yes. Power n can come out common. A times R power n minus 1 upon R minus 1 and whole power n is what we are interested in. What is this equal to? Is this equal to this power n? Yes. And is that the RHS? Yes. So that's the complete proof of this expression here, as you can see over. Is that all? Yes, that's all that you have in this question. Question number 15 says the pth, qth and rth terms of an AP are A, B, C respectively. Show that Q minus R times A plus R minus P times B plus P minus Q times C. Pth, qth, rth terms of an arithmetic progression are A, B, C respectively. Okay. So, pth, AP is equal to A, AQ is equal to B, AR is equal to C. And have you solved this kind of question before? Yes, a similar question has already occurred twice, not once, but twice in the exercises. Once for an AP, another time for a GP, and that. Okay, so for an arithmetic progression, this tells me AP will be, let arithmetic position is capital A is the first term, and capital D is the common ratio. So this is A plus P minus 1 times capital D, which is small a. A plus Q minus 1 times capital D, which will be small b. A plus R minus 1 times capital D, which is small c. This is what you have. And if that is the case, then can I observe Q minus R times A? A times Q minus R is what I am interested in. Okay, let's try to find that. Q minus R times A is equal to, multiply this with Q minus R, A times Q minus R plus D times, we have P minus 1 times Q minus R, which is P times Q minus R minus of Q minus R in the bracket, right, with D. This is what you have. Similarly, you can multiply B with R minus P, R minus P plus D times, you have Q times R minus P minus R minus P is what you get, right? The next term will be P minus Q times C. This and this and this, which is A times P minus Q plus D times R times P minus Q minus P minus Q. This is what you get. Is that okay? Yes. Now, simple addition of these three, what will that give me? Q minus R times A plus R minus P times B plus P minus Q times C is equal to A times Q minus R, R minus P, P minus Q will get cancelled. This will be A times 0 plus D times, what is this? In the bracket you have these and minus these. So minus these will be simply 0, that's what you can observe. Q minus R, R minus P, P minus Q will be simply 0. 8 terms will get cancelled. What about this? PQ minus PR is okay. So PQ minus QP is being formed. So PQ and PQ will get cancelled. Minus PR plus PR will get cancelled. QR minus QR will also get cancelled. Again 0 minus 0. So this is 0, this is also 0, this is overall 0. And this is what we wanted to prove. That's a complete solution for this 15th question, as you can see over here. Question number 16 says, if A times 1 upon B plus 1 upon C, comma, B times 1 upon C plus 1 upon A, C times 1 upon A plus 1 upon B are in AP, prove that A, B, C are in AP. Now, how will we go about proving this? So, there's one simple condition. There's one way which says, if A, B, C are in AP, this implies 2B is equal to A plus C. Yes, 2B is equal to A plus C. And the converse is also true, that if this, then this implies this. Okay, so I can get rid of this. ABC in AP implies this, and the converse is also true. So this is one of the methods which is useful in simple questions for that matter. Can this question be solved using this? Yes, this question can also be solved using this. But there's another idea which is useful for proving that numbers are in AP. If you are given A, B, C in AP, that implies that you can multiply the numbers by any number, any fixed number. Let's say KA, KB, KC will be in AP. Okay, if ABC are in AP, then KA, KB, KC will also be in AP. Common difference will be KD. This also implies that A plus lambda, B plus lambda, C plus lambda will also be in AP. So, the second point actually can be read as that if three numbers are in AP, you can multiply all the numbers by, or if you have an AP, you can multiply all terms of the AP by some non-zero number and still, or by some number and still the numbers will be in AP. If you are given an AP, you can add some constant to each and every term and the resulting sequence will also be in AP. Here the common difference changes, here the common difference remains same. Okay, so there are two ideas, and yes, those two ideas are used to prove such questions. let's take a look at this question using, first of all, I will use the second idea, which is easier in this, and then I'll show you calculations using the first idea. Right. So if A times 1 upon B plus 1 upon C, A times 1 upon B plus 1 upon C, comma B times 1 upon C plus 1 upon A, comma C times 1 upon A plus 1 upon B are in AP. This is given, right? These three numbers are in AP. Where do we want to reach? We want to reach this stage. A, B, C are in AP. If you see, I have A, B and C in the numerators. Just have something extra with all of these terms, yes? This is A upon B, A upon C. Something is missing from here. What is that? A upon A. Had there been A upon A, life would have been a bit simpler, right? Because 1 upon A, 1 upon B, 1 upon C will come in the bracket, right? Here also you can see B upon C, B upon A is there. B upon B is missing. Had there been B upon B, I would have taken B common, 1 upon A, 1 upon B, 1 upon C will be present over here. Similarly, over here. So for creating A upon A, B upon B, C upon C, what are we doing? A upon A is 1, B upon B is also 1, C upon C is 1. So we can add 1 to all these terms. Add 1 to each term. The resulting sequence will still be an AP. Yes. A 1 upon B plus 1 upon C, and that 1 can actually be written as A upon A for this one, comma B times 1 upon C plus 1 upon A plus 1 can be written as B upon B, comma C 1 upon A plus 1 upon B plus 1 can be written as C upon C. These three terms will be in AP. Yes or no? Yes. Can I take out A common from all these terms? Yes. What do I have? I have 1 upon B plus 1 upon C plus 1 upon A, comma B is okay. What do I have? 1 upon C plus 1 upon A plus 1 upon B, comma C is also okay. I have 1 upon A plus 1 upon B plus 1 upon C, and these are in AP. Yes, just simple analysis over there, simple calculation. Now do I observe 1 upon A plus 1 upon B plus 1 upon C, 1 upon A, 1 upon B, 1 upon C, 1 upon B, 1 upon A, 1 upon C. Over here, can I divide by this expression? Can I divide by these terms over there? Divide all terms by 1 upon A plus 1 upon B plus 1 upon C. You are dividing by this or you are multiplying by the reciprocal of this. One and the same thing, right? So dividing by this or multiplying by the reciprocal of this, if each term is multiplied with the reciprocal of this expression over here, then the resulting sequence will also be an AP. Multiplication by the same constant will also be an AP. This tells me A, comma B, comma C. You observe these will be the numbers. These will be in AP. Hence proved. Is that okay? Yes, that's the complete proof using this idea over here. What about the other idea, the first one, direct one? Will we be able to solve this question using that idea? Yes. But approach will look like this only. Why? Because you need to simplify the calculations here. So alternative method. If it is given that these numbers are in AP, I can write 2B 1 upon C plus 1 upon A is equal to first term A 1 upon B plus 1 upon C plus C times 1 upon A plus 1 upon B. Now if you observe carefully, what do I need to do? I need to remain, this 2B should remain as it is, A and C should also remain as it is, yes or no? Yes. These factors are creating problems, yes, and there are complicated things in the denominator. Simplification will be an issue. Yes. So how will we simplify this? We'll simplify this with simple common sense. What we'll do is, okay, let's add 1 to this term, add 1 to this term. If you're adding 2 on the right hand side, you should add 2 on the left hand side, yes. Next, 2b and 2, I want to take out 2b common. What remains is 1 upon c plus 1 upon a. Oh, there's no b over here. I give it a b in the numerator and denominator. This is what you do. Is equal to a times, I take out a common from here, 1 upon b plus 1 upon c plus 1 upon a remains. Similarly, I take out a c common, 1 upon a plus 1 upon b plus this 1 converts to 1 upon c, right? Take out c common. Oh, you've applied similar steps. Yes, I have applied similar steps so that calculations remain easy, right? And now I can cancel this factor. This is the same factor, so that implies 2b is equal to a plus c, which implies a, b, c will be in AP. Hence, proved. Is that a complete proof? Yes, that's a complete proof of this particular question, as you can see over here.